Hello everyone. Today we are going to discuss the domain name system, or DNS. Let's get started. Our objectives for this lesson are as follows. Understanding what is DNS, or domain name system, and how does it work in computer systems. We will also look into DNS queries, components, and records. Finally, we will discuss security concerns around DNS. Let's keep moving. So what is DNS? The DNS, or domain name system, is like the phone book of the internet. All devices on the internet, such as smartphones or laptops, need IP addresses to communicate to the web server to load the web page. DNS translates human-readable domain names, for example, www.google.com, into IP addresses that computers or devices can use to communicate. Now, how does the DNS work? We can explain the DNS workflow in 3 simple steps. In the first step, when a user requests a website by typing a URL into the browser asks the DNS server to find the server's IP address. The second step is DNS query and response. In this step, the DNS server checks its records and queries other servers to find the IP address associated with the domain name. In the last step, once the IP address is found, the user's browser connects to the web server and the website content loads. But is it that simple? Let's look at some of the message flows in the DNS request and response. The picture here shows the detailed message flows for a DNS query when a user starts to type google.com in the browser. In flow number 2, the browser queries the DNS resolver to translate www.google.com to an IP address. DNS resolver is typically managed by the user's internet service provider, ISP. Generally, the DNS resolver caches the DNS records of queries that were already translated to an IP address via the same resolver before. The DNS resolver returns the IP address if it has it in the cache. Otherwise, it will forward the query to the root server. In flow number 3, the DNS resolver forwards the request for www.google.com to the DNS root server. The root servers hold the name server details of the top-level domain, TLD, such as .com, .org, etc. www.google.com belongs to .com TLD. The root server responds to the DNS resolver with the name servers of the .com domain. In flow 5, the DNS resolver for the ISP forwards the request for www.google.com again, this time to one of the TLD name servers for .com domains. In flow 6, the TLD server responds to the DNS resolver with details of authoritative name servers for google.com. In flow 7, the DNS resolver forwards www.google.com to the authoritative name server holding the DNS records of google.com. In flow 8, the authoritative name server responds with the IP address of www.google.com to the DNS resolver. This time, the IP address is 172.217.165.132 as an example. In flow 9, the DNS resolver forwards the IP address to the user and holds the record in the cache till the TTL, time to live, expires. The user's browser then loads the contents of the Google website. Let's do a quick experiment. In your Windows command line, type the command nslookup www.google.com and see the result by yourself. You will find the IPv4 and IPv6 IP addresses associated with www.google.com. Now, what is a DNS query? A DNS query, also known as a DNS request, is a demand for information sent from a user's computer, DNS client, to a DNS server. In most cases, a DNS request is sent to ask for the IP address associated with a domain name. What are the different types of DNS queries? There are three types of DNS queries as shown here: non-recursive, recursive, and iterative query. In the non-recursive query, the DNS server returns an answer from its cache. In the recursive query, the DNS server will do the full lookup for the client. In the iterative query, the DNS server refers the client to other DNS servers for more info. Now let us look into the key components of DNS. These are DNS resolver, DNS root server, top-level domain name server, and authoritative DNS server. The DNS resolver is like a search engine for DNS. The DNS resolver is responsible for dealing with the client that made the initial request. The resolver starts the sequence of queries that ultimately leads to a URL being translated into the necessary IP. Root servers are DNS name servers that operate in the root zone. These servers can directly answer queries for records stored or cached within the root zone, and they can also refer other requests to the appropriate top-level domain TLD server. The top-level domain TLD servers are the DNS server group one step below root servers in the DNS hierarchy. A TLD server is a DNS name server that contains information for all domain names with a common domain extension. For example, a .com TLD name server contains information for all websites that end in .com. An authoritative DNS server is a computer that stores the official records for domain names and their associated IP addresses. It acts as a directory for web addresses and is responsible for providing the final answer to a user's query about a domain name's IP address. Now, what are DNS records? DNS records, also known as zone files, are instructions that live in authoritative DNS servers and provide information about a domain, including what IP address is associated with that domain and how to handle requests for that domain. These records consist of a series of text files written in DNS syntax. DNS syntax is a string of characters used as commands that tell the DNS server what to do. All DNS records also have a TTL, which stands for time to live, and indicates how often a DNS server will refresh that record. The most common types of DNS records are a record, CNAME record, MX record, and TXT record. Is there any security concern around DNS? The DNS is vulnerable to cyber threats due to its design and lack of security measures. Some of the most common DNS vulnerabilities include DNS cache poisoning, DNS tunneling, DNS hijacking, and DDoS attack. Let's explore DNS cache poisoning. DNS cache poisoning, also known as DNS spoofing, this attack replaces legitimate IP addresses with malicious ones in the DNS cache. When a user makes a DNS query, the attacker's malicious IP address is delivered instead of the intended one, redirecting users to fake sites. Is there a way to prevent DNS spoofing or cache poisoning? A solution is to use DNSSEC or DNS security extensions, which is a set of specifications for authenticating DNS requests and responses using digital signatures based on cryptography. Let's recap. DNS is critical for internet communication. It translates human-readable domain names into IP addresses so that the websites can load the contents on the client devices. DNS has multiple layers to ensure fast, reliable lookups. It is better to have an overall understanding of different components in the DNS query journey and how DNS works. Security measures like DNSSEC are important for protecting DNS from spoofing or cache poisoning attacks. In some other videos, we will discuss more on the DNS security and defense mechanisms. Thank you for watching the presentation. Now you understand how DNS powers the web. Please leave a like and subscribe to the channel if you like the video.